Hi there, my name is Darren Campbell. I'm a developer advocate here at PubNub, and this is a tutorial for our Kotlin Chat SDK. So this is a relatively new SDK that we've only just launched. It is designed specifically for developers who are creating chat applications from scratch or adding chat into an existing application. So just like with any of the existing PubNub SDKs, you have the same reliability, instantaneous message transfer, as well as scalability to scale to any number of users. But here we are providing the high-level concepts that a chat application needs, such as message threading, typing indicators, the ability to pin a message to a channel, innate understanding of users, and all of that is wrapped up within the SDK. So if you are an existing PubNub developer or you're familiar with PubNub, you've probably come across what we now call our core SDKs. So this is what provides the underlying message exchange. These are the low-level APIs that many customers use across a variety of use cases. You could create a chat application still using those core SDKs. However, in doing so, you make your life more difficult because we have taken a lot of those core chat concepts that you're going to need to have if you add chat to an existing app, and we have wrapped those up into easy to use, digestible APIs that we call our chat SDKs. So it's available for a number of platforms. You can see here we've got JavaScript, Unity, Unreal, TypeScript, and this tutorial is going to focus on the Kotlin Chat SDK. So I thought the best way to demonstrate the SDK was to put together a sample application to show some of the core fundamental concepts and principles, key classes, how things hang together. Much like with any other sample application, please do not take this as the basis for your production app, but hopefully it's enough to springboard you and get started. I tried to include some of the most basic principles of any chat application. So you see here we've got the different types of conversation that users could be in. There's public channels, there's one-on-one direct messages. I'll get into the implementation of these as the tutorial progresses, but the other features which the application has are the ability to send and receive messages. We have a understanding of user names as well as user IDs as people log in. It will read messages from history if you're late joining a conversation and there's chat that's already happened before you joined. You're able to react to messages as well as see the read indicator if your message has been read in the case of a direct message. And then not shown in this image, there is a typing indicator so you can see when the other person is typing, as well as, just to make things easier, there's a very basic login system where you can just choose a user ID and log in. So that's the sample application. In order to build it yourself, you can just clone the repository from GitHub, just like any other repository. So I will show that now. And then you can load that up in Android Studio. So at the time of recording, I think I'm on Android Studio Iguana, Ladybug. I can't keep up with these things. Open. Just wait for Gradle to synchronize, and then if we try and run the application, I'll just try and run it on an emulator here, just one I have previously downloaded. So everything's going to look okay, but if we go into the code, you'll see we don't yet have any PubNub publish and subscribe keys. Before you actually try and run the application, let's generate some of those keys. So what you do, you go to the PubNub admin portal, log in and create an application. There are other tutorials that will take you through some of the fundamentals of this, but what you need to do is create a key set that you're going to have associated with this app. So this is just going to be a testing key set. And then you need to make sure for any key set that's going to be used with the Chat SDK, you need to enable app context. So this is going to give you the metadata so the Chat SDK is going to associate metadata with users, channels, things like channel description or user name, user profile URL. You see the users had images in the previous screenshots. This is where that information is stored in app context. It is required to use the Chat SDK or any of our Chat SDKs, but we're talking about Kotlin here. I'm going to choose EU Central. Don't worry about any of these other events for this tutorial. More information obviously is available in the documentation for all of these attributes. And the other thing, which is not required by the Chat SDK, but this tutorial uses it, is message persistence. So this is the ability to read historical messages that have already happened in a channel. Just going to have one day, and then that is enabled. The other thing you might want to consider enabling for your application is presence. Now, this tutorial doesn't use presence, so I won't worry about enabling it, but this will enable you to see the user's online or offline status at the channel level, and it builds on top of the core SDK presence concept. So again, more information available in the documentation, but in order to just run this tutorial, the only two things you need are app context and message persistence. So now, having enabled those, we get our publish and subscribe keys. So copy those into the keys.kt file that we had in the project and rerun. And now when I log in, it offers me to choose a user ID. So like in a production application, you're obviously going to have some kind of identity management where the user will log in and they'll be given some kind of token associated with that. Like, yes, in production, that's how things will work. But in this sample, we can just choose any username and the user ID will just essentially be the same as the username. So I'm going to say Darren1 because I have no imagination. And there you go. It has created a general chat and a work chat. So just bear in mind, if this is the first time you're running this on a key set, you'll need to log out and then log in again. If you have previously logged in with any user, then these channels will be there for you. That is just a limitation of the sample. I wanted to have everything running on the client, so there's logic in there that says if the application has not been run before on this key set, then go ahead and create these public channels. At the risk of going into a little bit of detail, if you are one of our BizOps workspace users, you can even see that these channels have been created for you. They have an ID, they have a name, and they even have an avatar associated with them. So back to the application. Let's now run this on a different emulator. So I'll just run another device here. So having now installed the application on both emulators, I will log in as Darren. In fact, let me log in as Darren2 on the right hand side first of all. So the logic of the sample app is whenever I log in as a new user, it will create that user at the back end. And then whenever I log in, it will query the back end to ask who are all the different users in the system. And then it will offer me the ability to start a direct message with those users. In production, that's obviously not going to be the workflow that you go with, but it's a simple workflow that works for this sample app. So basically, we can both be in the same general chat as each other. So hello, remember I'm Darren1 on the left-hand side and I'm Darren2 on the right-hand side. Hello there. I can react to these messages. Notice how I reacted and then it immediately updated here. I can react again. And what else can I show? So they're the public chats. If I launch a direct chat, then you will see that if I start typing, you have the typing indicator is shown. If I go out and then I actually send this message, notice how the read indicator indicates that the message has not yet been read. But when I read the message, you can decide what reading a message means. And again, I'll get into more detail as we go through the code. But here, notice how it's gone to read as soon as I have loaded the chat. And that is the high-level basics of how the application works. I think the next thing to do is to dive into the detail. So first thing you do, if you remember, is there was a login screen, and this is where we provide, well, I called it a user ID. Essentially, we're asking the user to provide their name at this point. PubNub does distinguish between the user's name and the user ID. The user ID is a unique identifier for that user. It's what we use internally as the way to uniquely identify that user across any number of devices. Here, I'm keeping things simple by just sort of coalescing those two concepts, but the key is that as we get the user's name, we do need to parse that username for any invalid characters. Once I have the user ID, it launches into this home screen KT function. And then the first thing we do is to initialize the chat SDK. So if you're familiar with PubNub and like you've used our core SDKs in the past, the first thing you do to use those core SDKs is initialize the PubNub object. Here, the concept is it's identical, essentially. In fact, many of the parameters are identical between the two API calls. So if you see what we're doing in here is, if I just go to the implementation of create chat, we're calling chat.init, we're giving it a chat configuration, and we're building that with both the user ID, the subscribe key, the publish key. If you have other parameters here that you need to provide in the initialization, maybe you're providing the access token, it might be the typing indicator timeout is something which I could provide here. It defaults to 5 seconds, so I'm keeping the default, but I could change that typing indicator timeout if I wanted. So having now initialized the chat object, we really want this chat object to exist for the lifetime of the application. It is possible to have multiple chat objects in the same app. We discourage that for a number of reasons. So the best architecture is to just keep a single instance of the chat object. So you can see this is what I'm doing here back in the home screen, just keeping it in the state of the application. And then once we have this initialized, I go through some basic setup that's really specific to my sample application. You probably wouldn't do this as part of your production application, but I do things like if the user doesn't already exist, I'm just looking whether I have a profile URL or not, then give myself a random profile URL, make sure I update the user's name. And what that is doing, just to tie that back to some of the concepts I was talking about earlier, if you're a BizOps workspace user, you can see that it's gone ahead and created user objects for Darren1, Darren2. Associating this name with this user ID is what this line of code right here has done. And then the next thing the application does is to just detect whether it's the first time that this app has been run on the key set. So remember when I launched the app for the first time, I didn't have any channels, and then I logged out, logged in, I had the channels again. Probably not how a production app would run, but just to show the principles, that's how this is working. So all I'm doing is saying get channels. So this is the API to retrieve any existing channel in the chat SDK, and I can filter by IDs like public. So I'm actually calling my two hard-coded channels. I think it's public.work and public.general. And so if I have no channels, so this is the first time that the application has been run on the key set, I need to create those channels. So the way I create a public channel is this create public conversation API, and it takes a channel ID, public general in this case, a channel name, channel description, and I'm just giving it a general object, and that object is going to be the avatar URL for the channel. And I do exactly the same thing for the work channel. So I had a general channel, I had a work channel. It has a slightly different avatar, slightly different name, but all of the logic is identical. And then before I go on in the source code, just to show you where that was represented here, we have general chat, work chat. If I click into those, this was the avatar URL. It was a custom field. It's a public type of channel. And that's why I needed to use the custom object in order to store the custom URL. When you go about creating users, and we'll come to this very shortly, then the avatar of the user is actually part of the standard fields that you provide. The next thing the application does is to get all of the users in the system and sort them by who are the most recently updated, because maybe you've got more than 10 users, it's only getting 10 users, and it will just present those in the users list. So what this is doing, if I just log in again and show you, this is presenting this direct messages list here, and this allows you as the user to choose someone to talk to. Now, in a production application, keep coming back to that production application, this is probably not going to be how you do it. You would have some ability to initiate a new chat with someone. Maybe you could search by users. All of that is possible with the chat SDK by using this get users, and you can choose to filter by specific text string. We have demos that show that being done in other languages. If you'd like to learn more information at the end of the tutorial. But for here, we're literally just presenting a list of the 10 most recent users that we might want to have a conversation with. I should say, as a slight tangent, and I put this in the code comments here, in production, when you initiate a chat with someone, the recipient will get a invitation notification, not a mobile notification. It's an API that they will register for, and they will receive an invitation type message and they will know, hey, somebody's wanting to talk to me, and then they can join that chat. So having got our list of users, we put those into the list of people we can send direct messages to. So that's our one-to-one conversation. We also mentioned the public channels. So that's our many-to-many, essentially. But what we haven't got in this sample app, and it's worth covering briefly, is the Chat SDK does have the ability to handle group chat messages. And so the way I look at this is your public channels are your things like your Twitch chat or your live events where you've got like hundreds of people all in the same conversation, all reacting to content publicly. Anyone can join. Direct messages are easy to understand. That's a one-on-one conversation. But then the concept which isn't represented here, which is the group chat, think of that as your WhatsApp or Telegram group chat where you have maybe 10, 20 users. There is a limit. It's a lot higher than 20 that we support in the Chat SDK, but that's the kind of use case that you're talking about with the group chat. There are limitations as well to some of these. I think I covered them earlier on. For example, you can't have read receipts in public channels, and you wouldn't want them in public channels either. And then the remainder of this home screen file is mostly just drawing the UI associated. So there's obviously you're going to create a group of public channels, a group of direct messages. One thing that is worth pointing out is what happens when you click on a direct message. So previously when I created the public channels, do you remember I was invoking the create public conversation API? I was doing that as part of the initialization of the application, first time on the key set, just to create that public conversation on the back end. I only needed to do it once. Here, just again, to keep the logic simple, whenever I click on a person to initiate a direct conversation with, I call this create direct conversation with the user. Now, again, you only really need to call this once. The selected user is going to be the user ID that you are initiating the conversation with. If that channel already exists in the back end, then it will just return a handle to the previously existing user, and that will launch the chat window for that particular conversation. Again, you can see where I was testing this out earlier on in this tutorial, in that there is a third channel here. Now, this actually represents the direct channel. So the name here doesn't correspond directly with the user IDs. It is generated for you by the Chat SDK, but interestingly, well, I find it interesting, you can view the memberships. So because I created that conversation, it created the memberships underneath the cover, and this is important to understand as before we go into the next file and talk through what happens when it loads up that chat screen. But you see this channel has with it associated two users. There will only be two users in a direct conversation, but Darren1 and Darren2, the initiator of that chat, as well as the recipient of the invitation. Back to the application. Again, the rest of it is just UI. When you click either direct messages to initiate direct chat or to initiate a public chat, the sample app will use the same core logic, which is contained in this chat screen KT file. So let me just go through this chat screen file because there's a lot of key concepts in here that's important to understand. Firstly, and probably most fundamentally, is the list of messages which the SDK provides. So there is a message class, and this will represent a message that's been either sent or received by yourself, and this is displayed in the chat window. Here we have two messages, and there's text associated with that message. There's a sender in this case and a receiver over here. There is reactions we're associated with the message. So this has two smiley face reactions. And in the case of messages in a direct channel, there are also read receipts associated with that as well. So these are the read receipts down here. Like I said earlier, you will only have read receipts in direct or group channels. You won't have those in public channels, just the way that the Chat SDK has been designed. Header text, don't worry about that too much. That's just displaying this header text up here. And then the next thing that's worth pointing out is channel memberships. So earlier on, I mentioned how the channel memberships for direct channels will be created automatically for you when the channel is first created. But what I glossed over was public channels. Now, I am choosing to use the same logic for public channels as I use for direct channels. So what I'm doing is I'm calling channel.join for every channel which is rendered by this chat screen. Now, if you go through some of the documentation, the alternative way of receiving messages on a public channel, if I sort of go up here, I think I've got it loaded up. Yeah, here it is. I could have chosen to call this channel.connect API, and that will allow me to specify a callback, and that callback will be invoked whenever a new message is received on this channel. It means I don't need to be a member of the channel in order to receive messages. I don't get the benefits of being a member. So for example, I won't get the read receipts, but for a public channel, often that's okay. But there's nothing to stop you using the join method for public channels. And in fact, you can see if I go back to my public channels in BizOps Workspace, I've got general chat, work chat. All of these public channels have me set as a member for both of these users. That just means that I'm able to use the same logic that I use for direct messages. I use it for public channels. And when I say same logic, this is the logic that's down here. So whenever a new message is received in the channel, I update the messages array to represent that new message has been received. And then I also call set last read message on the membership object. So what I sort of skipped over slightly is that membership object has a number of APIs associated with it. The only API which this sample app uses is the ability to set the last read message, and we'll get to this in a minute, set last read message time token. The logic here is, do you remember I said earlier on, it's up to you as the chat app designer to choose when the recipient has read the message. So here, this is a read message, but how do you choose when that tick goes from a single sent tick to a double read tick? Depending on your design, you might choose to only show it as read when the user has the message within the window, within their scroll window, only when it's been within the scroll window for 2 seconds, or you might take the simplest case of whenever the user has that channel loaded in which the message is received, mark the message as read. That's the simplest case, and obviously I'm choosing the simplest cases with all of this here with the sample app. So that's all that's doing. It's saying whenever a message is received in the active channel, set that message as read. The message actions stream is responsible for, let's say this message has just been received. Whenever someone reacts to that message, so in this case it will be a very smiley face, I want to make sure that gets updated. So let's say we have the other user, Darren2, and they react to it. So because I have specified this handler, I might be belaboring this point slightly, but here we have the happy face that now has a 1 associated with it. So all of that same logic for newly received messages is then duplicated for historical messages. And I'm sure there's a way that you could do this more efficiently, but again, I just separated it to make it clearer to someone reading this code. So for historical messages, and let me just pause here and explain what I'm doing. So a channel, because we enabled presence way back at the start of this tutorial on the key set, every message sent on that channel will have a history associated with it of messages sent in the channel, and each of those messages will have the reactions and other metadata saved alongside that message. So what the Chat SDK will do is it will provide a get history API on the channel where you can say retrieve the past, and it will default to 25, I think, but here I'm saying get the last 20 messages sent on that channel and do the needful on those messages. Now, if you need more than 25, obviously there is there's paging support in the API, and details are available in the documentation, but I'm only just getting the last 20 messages just to keep things simple. And then the logic is exactly the same as for newly received messages. So every time I retrieve a historical message, I update the display so that it's shown, and I register for updates to the reactions on that message, and I set the last read message time token. If I just go out back into the main menu, this piece of logic here was responsible for, if I sort of say hello there, then it's currently sent. But now if I go back and I load the historical messages within this channel. So I've now loaded hello, and it said, okay, membership set large red message time token. If I go back, that will have indicated that it's now a red message. So let me just go through the rest of this file, make sure I'm not missing anything. We've got some logic here to display the header text and header profile. This is just going to be, so remember, this is either going to be a public conversation or a direct conversation. In the case of this sample app, it's just going to be the name of the person we're talking to and the associated image or the equivalents for the public channels. Message lists, this is a separate component. I'll talk about that next. And we pass in the messages and the read receipts. And then we've got the message input, which is this bit down here. A couple of bits to talk about here. So whenever we send a message, so if we hit enter or sort of return when we're in this field, we will invoke the send text API on the channel object. So that's the other end. And we talked about receiving those messages and registering for the callback when the message is received. Now this is the other end, actually sending the message, arguably the simpler side of it. And we also have some logic around the typing indicator. So I haven't spoken about this yet. I'll talk about this subsequently in the tutorial, but this is how we tell the Chat SDK that we are typing. If you look at some of our older documentation that talks about our core APIs, they'll talk about using timers and channel signals to like notify other people in the conversation that you're typing. The Chat SDK takes all of the complexity away for you. Literally, you have two APIs for the typing indicator, and whenever someone types a message in that input field, just keep calling start typing. Eventually, when they stop typing, then the message will time out. Chat SDK handles all of that for you. There will be a callback that's received. We'll talk about that when we talk about the message input. Again, not available for public chats, so just make sure to only call start typing for non-public chats. So next, let's talk about the message list object. So message list is not a class exported by the Chat SDK, but it's used by this sample app to just wrap the message or the list of messages within a lazy column and just render them within the UI here. There'll be an associated channel. So in this case, it's the direct conversation message object, and the read receipts are streamed at the channel level, like I spoke about just now. I'll go into that in a little bit more detail momentarily, actually. And then whether or not the message is sent or received, we're just comparing the user ID who sent the message with our own user ID, and if they match, then we sent it, else we received it. So the message object is a little bit more involved here. So let's talk about read receipts. Kind of dancing around this issue a little bit. So read receipts, when you register for updates, every time the receipts themselves update, you are going to receive it's an array of, you have the message time token, and that key is associated with a value, which will be an array of users who have read that message. So there's a couple of things there. Message time token is the unique way of identifying a message. So think of that as the message ID. And then the array of users who've read it, think of a group conversation, a group chat, and there's 4 people in my group chat, and I send a message, 2 people read that message. How do you capture that information? So in the case of the Chat SDK, that would be captured by having the message time token of the message that I just sent, and that would have 2 users associated with it, the users who've read it. The user IDs who are not part of that array would be assumed to be the users who've not read it. So that would enable you to update a UI in a group chat to say, read by, X and Y user. I'm not doing anything near that complicated in my sample app. I am just saying, well, find a message time token. So that is more recent than my message, or obviously has the same time token as my message. And then if it has more than 1 user who has read it, then assume the message has been read. So I'm not worrying about these partially read messages in my sample app. I'm just saying as long as someone has read this message or a more recent message in the channel, that's a key piece of logic that if you've read a more recent message, you assume that all prior messages have also been read, then mark the message as read. And I'm just saying is read this variable up here, set it to true. The rest is fairly self-explanatory. So we have we're just displaying the user's name, their avatar, and we have the text associated with the message. So that's retrieved by message.text. The reactions, obviously in production, you will have a dynamic list of message reactions. You won't be relying on just having two reactions. Well, I don't know, maybe it's up to you. You have complete control as the developer of your application. But I would guess you have a dynamic list, but here we just have a static list of two possible reactions. And if I go back down here, this is the logic for displaying the sent message. So here I'm saying my two message reactions, and if it's been read, then display the 2 ticks, else just display the 1 tick if it's only been sent. Let's talk about the message reaction type. So message reaction, the message, remember message is coming from the Kotlin Chat SDK, has a field called actions. Now we store a number of things in the actions field at the SDK level, but one of those things is the reactions. So reactions are the emoji, are these things essentially that have been applied to the message. Now remember, the emoji itself, that's just a string. So again, if we go back to message, we have two hard-coded emoji in this sample app. We have this one and we have this one, which I just chose because they looked good and funny. But what you do in order to get the number of reactions of any one type is, so there's this reactions array, which is a list of key value pairs, and the key is the emoji itself. So by saying get emoji, I'm getting all of the values associated with that key, and that value is going to be the list of users who have reacted with that emoji. Now, in this sample app, I don't care who reacted because I'm not hovering over it to see Darren1 reacted. I'm just looking at the number and I'm displaying that number in a very small text field there. So yeah, literally all I'm doing is getting the count, and I am displaying that count in a text field alongside the emoji itself. So once you get your head around how reactions are stored at the message actions level, everything falls out of that. The only caveat, and it's a good caveat, is in the core SDKs, you had to manage this yourself, whereas in the chat SDK, this is all managed for you. If you retrieve messages from history, then the actions and therefore the reactions associated with those messages are all retrieved for you at the same time. So you don't have to worry about get messages and then get message reactions associated. That's all handled automatically for you. So what next? Let me just talk about the message input and the typing indicator. So message input, there's not much to. We just have some message text associated with the text which I'm going to send. I apologize. I know my camera's in the way, but I think the message comes across. So yeah, we just have a text field provided by Kotlin, styled. When the value changes, update the message text, send that start typing. Do you remember earlier on I talked about the start typing API, which is sent on non-public channels to indicate to the chat SDK that somebody is typing in the conversation. Will also work for group chats as well. And then we also have associated with the channel the typing indicator object. So typing indicator, again, I've kept it quite simple in this sample app. This is, if I start typing, you see it comes up typing Darren1. If I was to go over here, I've got to do it quite quickly because the timeout is like 5 seconds, but I'll go back. Okay, typing Darren2, and I can even have two typing at the same time. That's not as easy to do at scale as you would think, to have like multiple users and they stop typing at different times. The Chat SDK provides all of that for you. And I mentioned the start typing API. The companion to that API is the get typing API. Again, it's on the channel. You give it a callback. So here I'm just going to store the value that's received whenever the callback is invoked. That callback will be invoked whenever the list of typing users changes. A couple of suggested improvements that I mention in this sample app here. The first one is you probably don't want to tell the user when they are typing themselves. That was just to make it more obvious to yourselves that how this is how everything comes together and works. The other thing is you might want to display, rather than this is the user ID that's being displayed at the moment, you might want to display the username, their avatar. You could, every time you get this callback invoked, you could call chat.getUser with that user ID, and then with the information that's returned, you could display the profile image, you could display the name. The thing is that gets quite inefficient, because you're making a call, a network call, every time you're getting one of these callbacks, which can be quite frequently. And so you probably want to cache this information. So I didn't want to implement an inefficient mechanism and then someone copy and paste that into their application, and that gives them usage issues and performance issues. So yeah, I've just put it as a suggested improvement, and I've shown the high level of how you might expect that to work. And hopefully you can take this and make a really nice looking typing indicator. So that covers the feature set of the Kotlin sample that I put together for the Kotlin Chat SDK. It's obviously a lot more capable than that, the SDK itself. If you go to pubnub.com/docs, then click on SDKs and Kotlin Chat SDK, you'll see all of the APIs available, as well as little code snippets and miniature samples. We have a lot more methods. I mentioned group conversations, but I didn't cover things like deletion of channels or push messages. Obviously, push messages fundamental if you're writing an Android application, marking messages as read, having dynamic updates to channels or dynamic updates to users. All of that was missing from my very basic sample. If you want to see some of these features in action, like message threads or the ability to pin messages to channels, I recommend checking out on our demos page. It's not in Kotlin, it's written in React. I wrote it. So there's a chat demo, and that will go through a lot more of the features, like inviting users to channels, where it's that more production style of creating a group of 3 users, and then all of those users get invitations and then they can join. And we also have an example of presence. So remember I mimicked presence previously, where here we show real global app presence. Threads, unread messages, being able to quote message or include links or mention users, all of that is available in our online demo. So please check it out. I recommend it. If not, if you have additional questions, then please get in contact with me or the rest of the DevRel team at devrel@pubnub.com. But other than that, thank you for listening and good luck with your development.